viewers, and welcome back to Fermi Physics Solutions. This is the Concept Explainer series. This is the first video looking at the concept on explaining forces. So what I want you to do is just take a look at these two balls here, and what we're going to do is I'm going to make the two balls move and just take a quick little look and see, do you notice any difference about how the balls move, or maybe notice if they're identical types of movements, what makes them the same. Okay, so that probably happened a little bit fast. I'm not sure if your eyes would have really picked up anything there, so you might not have noticed whether they were different or whether they were the same, or taken in the information to make either judgment because of the speed in which that happened. So let's maybe slow it down a little bit. So the first ball, the blue ball, I'm going to move it. And we can see it moves a little bit, speeds up, speeds up, speeds up. Second ball, as you can see, moves at a constant speed across the right-hand side. So we'll just have a look at that once again quick. Speeds up, speeds up, speeds up. Second ball just moves at a constant velocity apart from the start and the end when it moves from left to right. So what I'm going to do is I'm just going to set up a load of cameras across the way. And what that camera will do is that will just take a photo for me every 1/10 of a second, and we can actually kind of observe the different motions between the two balls. So after the first 1/10 of a second, I can see that the blue ball hasn't really traveled too far, and the green ball has traveled nearly twice the distance in 1/10 of a second. The next set of cameras will go off, and we can see that the blue ball, if we look at the arrows, has increased the distance that it's after moving in that 1/10 of a second, but the second ball has actually moved the exact same distance again. So the blue ball, for the first 10th of a second, moved a small distance. For the second 10th, it moved a slightly bigger distance, while the green ball is moving the same distance for the first 10th and also the second 10th of a second. Do the same thing again, and we can see that the blue ball has now moved a bigger distance again in 1/10 of a second. It still hasn't caught up with the green ball, but every 10th of a second, it's moving more distance to the right hand side, while the green ball, if we look at the arrow again, it's moved the exact same distance in 1/10 of a second. And finally, the last set of cameras go off, and we can see that the blue ball has again increased and covered more distance again in that 0.1 of a second, while the second ball has moved at the same distance again. So we have two types of motion that we see here. The first one is called an increasing velocity, which means that its speed and velocity increases to the right as time goes on. We can call that an accelerating body. And the second thing we have there is a body that's moving at a constant speed or constant velocity, and it's a non-accelerating body. So the blue ball is accelerating to the right, while the green ball is moving with a constant speed or a constant velocity to the right. So this gives us an idea of what an acceleration is. This is kind of an overview as opposed to a strict definition, but when you think of accelerations, this is what you should be thinking of. An acceleration is observed when the motion of a body changes. In general, we say that's when an object speeds up, slows down, or changes its direction of motion. But you can summarize that as it's just the motion of the body changing. So whenever we see an acceleration, motion changes, and that's an important thing for us to keep in the back of our head when we're thinking about forces. So we're going to look at the most simple forces that we've always been familiar with, and that's the gravitational force. Gravitational force, as you know, and you might use the word gravity for this instead, is what basically keeps things on the surface of the planet. So if we drop an apple, we know that it's going to fall to the ground, and it's going to try and fall to the center of the planet, and it'll keep moving until it hits the ground, in which case it'll stop its motion. So let's just look at a simple idea here. We have a tree, and we have an apple that's just about to fall off the side of that tree. So what I do is I set up my array of cameras again, and what I'm going to do is I'm going to take a snapshot of the apple as it falls, because I want to see how does it fall. I want to know, does it fall like the blue ball, in which it accelerates, or does it fall like the green ball, in which it falls at a constant velocity? So I start taking my snaps, just a second that goes, And I can see, looking at this, that this strobe diagram here, that reflects what we saw in the blue ball diagram. And this tells me that when the ball falls under gravity, it's not going to fall with a constant motion, but it's actually going to fall with an acceleration. So its velocity is going to increase until it hits the ground. This gives me an idea of what forces do, and I see this in other places again. If I take a car from starting and I put my foot flat down on the accelerator, as long as I do it in a way that the engine isn't going to cut out, then I will notice that my car will start to accelerate as it takes off. And it will cover more distance for every unit of time as I keep my foot down. Now, there is a peak that happens with your car, in which case your engine's hit its max output, and also your air resistance and your friction and the wind and all will stop you from speeding up anymore. But we do get this feeling at the initial acceleration of a car. We also see this again when we set a rocket. So if we take a rocket and we burn off its thrusters to take off, we notice that in a unit of time it only moves a small distance, but it will cover more distance as long as the engines are burning. And it will accelerate upwards until it gets to the point where it's able to fall into orbit or even move out of orbit of the Earth. So this tells us what forces do. When I looked at those three diagrams, the apple, the car, and the rocket, we noticed that in each case, even though they were different scenarios, the same thing happened every time. There was a change in motion of the body. So we can say that a force causes a change in the motion of the body. The first force we saw was gravitational. The second force we saw was the output from the engine. The third was the thrust coming from the rocket. Even though they're different forces and they're all acting in different contexts, the same thing was observed. The force caused a change in the motion of a body. To bring a more formal definition, then, that tells us that a force is what causes an acceleration of a body. So anything that will cause another object to accelerate, to speed up, slow down, change its direction of motion, that is called a force because it causes those accelerations. There are generally two types of forces that you come across. There are the contact forces, in which objects have to make contact in some way, shape, or form in order for the force to act. And there are non-contact forces where the objects don't need to contact each other at all. There's only three non-contact forces which I'll present at the end. So in general, when you know all three non-contact forces, if you're ever presented with another force, it has to be a contact force. So it's actually handy enough to categorize the two of them. The most common contact forces you're going to come across are the following six. Although there are more outside this list, but this is the common six. When two objects touch off each other to push and or pull off each other, we call that an applied force. Well, sometimes we call that a mechanical force. And in general, everyday conversation, you might just regularly just call that a force or a push and a pull. But the correct terms for that is either an applied force or a mechanical force. So again, the most simple idea, you're pushing a box or you're pushing the trolley around the supermarket. Friction is the perpendicular force that happens from two surfaces in motion against each other. So the easiest way for you to feel this is take your hands and rub them together. You will generate heat because the friction between your left hand and your right hand is the force that's opposing that motion. If you're ever on a bike and you fall off and you graze your leg, the graze happened because as you were moving forward when you fell, the contact between the ground and your leg generates a frictional force that acts behind you to slow you down, and that's what grazes off the top layer of skin of your leg. Okay, the important thing to note is that the friction acts perpendicularly along the two surfaces in contact here. So it's these surfaces in contact where the friction is acting. Okay. Next thing is the tension. So if you take any sort of wire or cable and you pull it so that it's taut or tight, that is what we call the frictional force. If you've ever played guitar and you've snapped a string, you will know that the snapping of the string can give your hand a bit of a sharp hit with the string, because when the tension's released, you have a very fast moving string then that comes and hits your hand. Thrust, as we looked at before, comes out of rockets and engines of things like planes. So thrust acts as a force as the chemicals are burning and they produce a thrust, um, which allows the either plane or the rocket to move in a forward direction. Buoyancy is another one. In this case, the force of gravity is trying to pull a box down into the water and trying to make it sink, but the water itself is also uh, imparting a force onto that box, which is making it float. So that upward force is what we call the buoyancy force. Other people sometimes call it the upthrust as well, but buoyancy is a more common term for it. Air resistance, when you're driving down a car, obviously you're driving into the air and the air is going to push back along against you. So that's what we call air resistance, sometimes also known as drag. Okay. If you ever want to feel this force, it's very, very easy. Just when you're driving a car on a clear road, put your hand out the window, lay it flat, and you will feel the air pushing against your hand. So like we said, they were your contact forces. You have three non-contact forces, and they're very, very easy to remember. Your first of your non-contact forces is called the gravitational force. This is generated by any object that has mass and pulls other objects towards its center. Generally, it's a weak force, which is why it's only noticeable when you have really, really, really big objects. For instance, things like planets and suns. If you sit beside another person about 1 meter away, there actually is a gravitational force between you and them. But because your body is relatively small and so is their body relatively small, that force is so weak it doesn't even register with any of our nerve senses, and it's not a strong enough force to actually cause us to move towards each other. We also have the electrical force. The electrical force is the force between charged particles, which we'll look at later on. But as a general rule, oppositely charged particles will attract each other and similar charged particles will repel each other. We also have the force of magnetism. And again, magnetism comes from the interactions of the poles of magnetic materials. So again, it behaves in a fashion that's similar to electric charges, although they're not the same force, and they don't interact with each other directly either. So magnetic materials will react with other magnetic materials, or sorry, they'll generate forces on other magnetic materials, but charged materials and magnetic materials don't necessarily put forces onto each other. The way magnets work is similar. Poles will repel each other, and dissimilar or opposite poles will attract each other as well. Again, main thing to remember is what are your three non-contact forces: gravitational, electrical, and magnetism. Everything else then is a contact force.